Hello and welcome to my channel ZeroToSiva. In last video, you understood about the Mule runtime engine. Actually, it was a long video, I know, for 1.5 hours. So I'm putting this topic, NIO and Grizzly, in day 3. So in this video, you are going to understand about non-blocking IO and what are these Grizzly thread pools. So let us get started. Actually, Mule internally uses non-blocking IO, especially the HTTP component of Mule 4 is using non-blocking IO. It internally, of course, uses a framework called as Grizzly, which implements this non-blocking IO efficiently. So we need to understand about non-blocking IO to understand the internals of how Mule works. So actually for me also it was very confusing and I was unable to visualize properly until I understand about NIO. So I've done a lot of research on NIO and I have understood how it works. I'll present it in a clear way. If you are listening for this for first time, it might be confusing to you as well. So feel free to watch the video again and again until you understand it. Okay, I'll try to put it as simple as possible. So let us take a scenario. Let's assume that forget about Mule for some time. Okay, let's talk about how a normal HTTP server works. HTTP server. Let's assume that this is a HTTP server which is not using NIO. In olden days, when there was no NIO concept, how the HTTP server used to work. So in HTTP server, there will be a thread running on a port. Let's say 8080 port. There will be a thread running on this port. So normally in our program, if I am writing my own HTTP server, what I do is I create a server socket at this port. Server socket at this port, and it will start listening. My thread will start listening. Now let's say one client application, let's say it's a browser or any client, it makes a connection to this socket which is listening at 8080. So what this thread will do is, this thread which is listening on 8080, it will create one more socket object and create one more thread. So now this thread will use this socket and communicate with the client. So like that, if there are 10 clients like this, all the 10 clients will first initially make a connection to server socket. So for all the 10 clients, what will happen? 10 server sockets, so 10 separate socket objects. So this is a socket object. So there is a difference between server socket and a socket. Server socket is actually used for listening on a port, and socket object is used for actual communication. Once any server accepts a connection, a server socket will create one socket with a port, and this socket will be associated with another thread, and from now onwards the client will send the information to this socket only and they talk to each other, right? So if there are 10 clients, there will be 10 threads and 10 sockets. But when a client is making a call to my server, it is a network call, right? So normally the network calls, the data which is exchanged depends upon the network speed and all. So if the data is coming at a slower rate, the data is not available, my thread is blocked. It will be waiting for the data, right? So that is the idea. But if I go a little bit internally, whenever my socket tries to read from a network, there will be a device driver in my operating system which will be used to talk to network, right? So just I'll write it here. There will be a device driver and there will be a network card on your machine, right? Network card, which actually takes care of doing all the network operations, right? I just wrote it separately in diagram. So this network card is a hardware. So this hardware knows how to make network calls, right? But in my operating system, for every network device, there will be a device driver, and inside the network card, there will be a software component. Actually, network card is a hardware, right? In every hardware, there will be a device controller. Okay, so you need to understand this a bit. So I'm telling it whatever is required. Now, whenever my socket tries to read from the network, it will actually delegate to device driver of my operating system to read. The device driver will ask the device controller to read. Then the network card will try to read from the network. This is how it works, right? So who will actually get the data from the network? The device controller will get it. So it might be slow, right? So until there is data given by the device controller, my thread will be in blocked state. My socket will be waiting. Once my thread called socket.read, once it uses socket to read the data, the thread will be blocked. So this is a scenario of blocking IO. We didn't discuss about NIO. So if the HTTP server is not using NIO, what will happen if there are 100 clients? 100 threads will be there with 100 sockets, but those threads may be blocked because of a slow network. So my CPU time is wasted. Now let us see the same scenario if my HTTP server is made to use NIO. So before we discuss about NIO, let us try to understand some concepts. So in case of NIO, what we do is we use something called as channels to read. So in case of reading from socket, there is something called as socket channel, right? So my thread, what it has to do is it has to use socket channel dot read. Okay. Normally, once the data is available with the channel, what we do is whatever the socket channel reads, we populate it inside something called as a buffer. The data whatever we read will be populated inside the buffer. Okay. So my thread calls socket channel.read. Once the channel got the data, it will be populated inside the buffer. This socket channel, what it will do, of course, it internally talks to the device driver, and the device driver internally talks to the network card in our case, okay, which is a hardware, and this has a device controller, right? So this will talk to the network, and when the data is available, it will give it to driver. Then driver will give the information to channel. Now the channel has data, but until channel has data, my thread is waiting because of slow network. So what we can do is we can make this channel, socket channel, as async. There's a configuration. Once we ask this, we configure the socket channel to be asynchronous. Once we call channel.read, my thread will not be blocked. It can go and do some data, do some work, right? So we can call channel.read asynchronously. Okay. So if you want to read the channel data from channel asynchronously, what we need to do is we need to do something called a selector object. Selector is an object again, and what we can do is once we create a channel, we can register a channel with a selector. Okay. It is possible that multiple channels can be registered with a selector. Okay. Now what I can do is, actually what the main thread, what is the main thread doing? Main thread will be listening for connections. Whenever there is a connection, it will create a channel and register it with selector. That's all. The main thread is not blocked. Okay. Now what we can do is we can use another thread to call selector.select. Selector.select. Whenever this thread calls selector.select, this is a blocking call. So this thread will be waiting until at least one of the channel is ready. So let's assume two channels are ready with the data. So now whenever channels are ready with the data, selector.select will get an array of this channels. Okay. Now what this selector thread, I can call this as a selector thread. What the selector thread can do, for each channel it can start one more thread which can process the data from this channel, right? This is what can be done. So what happens in this case, whenever the data is ready with the channel, right, whenever the channel is ready, I would say the selector is intimated. The selector thread will be waiting until then. Selector will be intimated. So now if there are 10 channels registered with a selector, and if only 3 channels are ready with the data, what is happening? My selector.select will return an array of 3 channels, and then my selector thread will start 3 more threads to read the data from the channel whatever is ready and do the processing. So here we are actually processing the data when it arrives. None of our threads are blocked, right? So we are actually reading the data without blocking, non-blocking IO, right? NIO we say, non-blocking IO. So let me actually try to explain this concept using a HTTP server. Okay. So normally if this is my HTTP server, in HTTP server there will be one thread which will be listening on a port, right? So actually this server socket, this thread will be using something called as server socket channel. Server socket channel. So using a server socket channel, we will create a socket and it will start listening. Now if any client makes a HTTP call, let's say, this will accept the connection and it will create one object called as socket channel. You can just visualize this socket channel like this. This is a normal socket channel, and it will register this socket channel with the selector. So if there are 3 clients which are connecting to the server, what will happen? 3 socket channels will be created and they will be registered with same selector. So actually how many threads are there initially? There will be only one thread which is listening till now, right? Now I am saying there will be one more thread on the server which will be calling selector.select in an infinite loop. So let's say there are 3 channels registered with the selector and all the 3 channels are not ready with the data. They might be waiting for the data from the clients, right? They are not ready with the data. So the selector.select, this is selector thread I am saying. Okay. The selector thread will be waiting until one of the channels are ready. The selector.select call will be blocked. Let's say now there are 2 channels which are ready with data. Selector.select will return array of 2 channels. Then what the selector thread can do, it will be internally maintaining something called as worker threads. Okay. So now once two channels are ready, what it can do, this selector thread, it can delegate the processing to worker threads in the pool. This is a worker thread pool. So as and when data is ready with the channel, when the channel is ready with the data, then my selector thread is delegating the processing of the data to another thread in the thread pool. So data is processed asynchronously. No thread is blocked waiting for the data from the IO devices, right? So that is a non-blocking IO. But it is also possible in some of the implementations, what they do is they will not be having worker threads in some of the HTTP server implementations. What they do is they will be having a pool of selector threads only. There will be a pool of selector threads. Let's say I have a pool of 5 selector threads. Okay. Now, what this main thread might be doing is there will be 5 selector threads, means 5 selector objects will be there. Yes. So, whenever a connection is accepted by this main thread, it will create a channel, right? And this main thread will register this channel either to this selector or this selector or this selector or this selector. Among the 5 selectors in this case, it will register that channel with any of the random selectors using some algorithm, of course, right? So now what? Each selector thread will have some channels associated registered with it, right? So this thread called select.select, and if this selector is assigned 3 channels, these 3 channels, when the data is available from any of these channels, now this selector thread only will have the logic to process. It will not delegate it to worker thread. Again, some of the servers thought, why to delegate? There will be a lot of thread switches. Instead, the selector thread itself will process the data from the selected channels, right? This is the concept. So now let us come to Mulesoft. In Mule, we are using HTTP connector, right? HTTP component internally is using a framework or a library called as Grizzly. So Grizzly is a framework which is implementing NIO, and Grizzly maintains selector thread pools. As I told, there can be a pool of selector threads. So it will be maintaining selector pools. So for our HTTP listener will have one main thread which will be listening for requests on a given port, right? So this main thread will internally delegate to this Grizzly thread pool, right? So every HTTP listener will be using a separate thread pool. In earlier video, we understood that there are 3 thread pools like CPU light thread pool, CPU intensive thread pool, blocking IO thread pool. Yes. But for HTTP, for listening for HTTP requests, there will be one more thread pool called as Grizzly thread pool, which is managed by Grizzly, and that is actually using NIO, so that the threads in this selector pool will never be blocked. It is NIO, non-blocking. Okay. And one more important thing is, suppose if you are running your applications in a Mule runtime, this is a Mule runtime, there can be application A running, application B running, application C running. And in application A, let's assume that you have 3 HTTP listener flows. Assume. And these having 2 HTTP listener flows, and these having 1 HTTP listener flow. A flow which is containing HTTP listener as inbound. Okay. So there are 6 HTTP listeners, right? Can you guess how many Grizzly selector thread pools will be there? For all the applications, it is only 1. So in one runtime, there will be one shared Grizzly thread pool. So all the HTTP listeners in all applications of a single Mule runtime will be sharing the single common pool, right? And in your flows, you might be using a HTTP requester, right? HTTP requester. So every HTTP request will have its own dedicated Grizzly pool. Whenever it is making a request, also it's doing an IO operation, right? There also we need non-blocking IO. The concept is same when it is making a request, but for HTTP requester, a dedicated Grizzly pool will be available. That means in your application, let's take an example. So let's assume that this is my Mule runtime and this is my application A and this is my application B. In my application, I am configuring 2 flows, 3 flows, let's say. Okay. And in these 3 flows, I am using HTTP requester. So every HTTP requester will be having a dedicated Grizzly pools. Let's assume that these 2 are making a call to REST API 1. And this is making another call to another REST API. Right? So how many dedicated Grizzly pools will be there in application A? Can you guess? So there will be only one dedicated Grizzly pool per application. Per application, remember. So earlier for HTTP listener, there will be one shared Grizzly pool per Mule runtime. But the Grizzly pool for HTTP requester, which will be used as one per application. Okay, keep that in mind. And wherever our Mule components are making IO calls, it is whether it is HTTP listener or HTTP requester or maybe a SOAP web service consumer, wherever they are making IO calls, even a file reader, right? File component, or wherever they are making IO calls, they are internally using non-blocking IO like this. Okay.